Hello students, welcome back to our maths lessons. So in today's class we'll learn about circles. So our objective for today is we'll learn about the basic parts on the circles, and then we will see about the tangents versus secants difference and some theorems and some challenging questions. So let's zoom in.
From bubbles, bangles, donuts, pizzas, to wheels, so many things. No wonder the circles rule our world and command so much attention. So let's get started on this amazing shape. A circle, for example, have various parts to it, we know that. And center is the point inside the circle, and all the points on the circle are equidistant. So that's the quality of the center. The radius of the circle is the length of the line from the center to any point on its edge. So whatever any point we can choose, the radius will be constant. And plural, we call it as radii. Double the radius, we call it as diameter. So diameter of a circle is the length of the line through the center. So it passes through the center and touching the 2 points on its edge. So it should touch the 2 points on its edge. That's the quality of a diameter. So twice the radius is the diameter. Now coming to chord. So the chord is the line segment. We know the difference between line and line segment. Line segment means it should have 2 end points. So the chord is also a line segment having 2 end points, for example A and B, whose end points lie on the circle. Okay, can you guess the number of chords that we can draw in a circle? Pause the video and think for a while. Yes, you are right. We can draw infinite number of chords within a circle, because there are infinite number of points that include the circumference of the circle. Interesting thing to note is that the chord that passes through the center of the circle, we call it as diameter. And diameter is the longest chord of the circle. Coming to arc. Arc, as you can see in this picture, is a part of the circle. More accurately, it is a part of the circumference. It is the curved part of the circumference. Any 2 points can form an arc. And the shorter one, we call it as the minor arc, and the longer one, we call it as the major arc. Coming to sector. So sector, as you can see in this diagram, it is a region within the circle. It is a part of the circle that includes an arc and 2 radius. So now you can relate it more accurately, right? Much better. So the part of the sector is that area which includes the radius, the 2 radii of the circles, and an arc of the circle. Coming to the segment, as you can see in this diagram, it includes a chord. So PQ are any points on the circumference, and we can draw a chord out of it. So the segment is the region which includes a chord and an arc of the circle. You can relate this segment much accurately with a breaking of a biscuit or a breaking of a cookie, right? Just a revision, so you can see in this picture the area which includes the 2 radius and an arc form a sector. The area of the circle which includes a chord and the arc of a circle, we call it a segment. Now let's learn about the circle and line in a plane. Now for a circle and a line on a plane, there can be 3 possibilities. Let's explore what are they. The first can be that the line and the circle can be non-intersecting. They don't meet each other, right? The second possibility is that they can have a single point of intersection or a common point of intersection. Or the third possibility is they can have 2 common points. In this case, the line cuts a circle. Let's see the diagram. So here you can see the first possibility, that the circle and the line are non-intersecting. It doesn't meet each other. The second possibility, as you can see, that they meet at one common point. Okay, so they just meet at a specific point. Just to remind you, this point, if the line outside the circle meets a circle at a specific point, we call it as tangent. Okay. Now this is the third possibility, where the line segment cuts the circle into two parts. Two equal or unequal, doesn't matter, but two parts. Okay, and they intersect the circle at two different points. Okay, so here we see that we call it as secant. The line PQ, we call it as secant. Let's learn more about tangents. So you can see this is a diagram. This is a circle and it intersects the circle at one point. It meets at one point, so we call it as tangent. So tangent to a circle is a line which touches the circle at exactly one point. That's very important to remember. Okay. Second thing is that there can be many points on the circle, just we discussed before, a couple of moments before. So there can be how many tangents in a circle? There can be infinite number of tangents within a circle, right? So for every point on the circle, there is a unique tangent passing through it. We cannot draw two tangents from a single point. So if there is a single point, there can be one tangent to it. Here we can see that this is a tangent, okay? And we take the tangent a little bit downwards and we see that it intersects at two different points, right? And it becomes a secant. So we can say that a secant intersects a circle at two different points. And yes, as you know that this one is the tangent as it meets at only one point. Let's look into this figure where the circle is there and a secant is there and it intersects the circle at two different points A and B. Now interestingly, the part AB which lies within the circle, we call it as chord. So chord is a part of the secant. So secant cuts the circle at 2 points, any 2 points, forming the chord of the circle. Now one important property of every circle is that the tangent is a special case of secant. We know that this is a line segment, this is a line, or this is a point A. Okay, now think about how many line segments or lines can we draw from this particular point A and this circle. So let's think of this another line segment AB, and this is the second line segment we can draw from this particular point A, right? This is the third line segment we can draw from this point A, and so on. So interesting thing to note is that we can draw only one tangent for a particular set of circle and a point. Okay, we can draw infinite secants, but we can draw only one tangent for a particular point and the circle. Clear? Let's check your understanding. My question to you is that how many tangents can be formed for a given secant? Think about it and write the answers in the comments below. Let's discuss some important properties of the circle. The tangent at any point on the circle is perpendicular to the radius through the point of contact. So let's see here, what does it mean? So if you take a circle, okay, and this is a tangent, so it meets at a particular point of contact. This is the center and this is the radius from the center to the point of contact of the tangent, right? So this makes an angle of 90 degrees. This is a very, very important property that will be used in many questions. Okay? Okay, let's proceed. The second property, so the number of tangents drawn from a given point is the second property. Let's check how many number of tangents we can draw from a particular point. If this is a circle, this point is inside the circle. So this is the interior region and this is the exterior region, right? So the point lies within the interior region of the circle. So we can say that we can draw no tangent if it lies inside the circle. So no tangent can be drawn to a circle which passes through this particular point that lies inside the circle, because tangent always lies outside the circle within a point of contact on the circumference, right? So we can say that if the point is inside the interior region, no tangent can be formed for that particular circle and a point. If the point is on the circle, you can understand that we can draw one particular tangent, right? So the point, you can see that it is neither on the interior nor on the exterior, it is on the circumference. So we can say that only one tangent can be formed. So this is the point of contact. We say that point of contact between the tangent and the circle. If the point lies outside the circle, okay, let's see what happens. So let's take a circle, let's take a point, okay, let's name it as point P. Of course, we can draw one tangent which touches the particular circle. We can draw a second tangent as well, okay. So this is, for example, we name it the point of contact as A and B. So we can see that for a particular set of points which lies outside the circle, we can draw two tangents. Okay. Now let's discuss some important theorems. First theorem that we'll see is that two tangents are of equal length when the tangent is drawn from an external point to a circle. Just now we discussed. So what happens that two equal tangents form a circle. Let's take a circle. This is a point, okay, that is point P, and the 2 points of contacts are A and B of these two tangents. We see that PA is equal to PB. Okay, through congruency we can prove. The second important theorem to remember is that two equal chords subtend equal angles at the center. Students, please note down the theorems within your notebook so that we can apply them while we are doing the problem. So this is the second theorem. What does it mean? Let's see. So equal angles at the center of the equal chords. So this is a circle. Let's take a center as O. Okay. This is a chord and this is second chord. Name it as AB and CD. Okay. Now we make the angle at the center. So we join A and B, right? Similarly, we join CO and OD. So what we can say that the angles COD will be equal to angle AOB. The given it is that AB equal to CD, and we need to prove that these two angles are equal. Okay, let's see. Let's prove that. So this region, in order to prove these, we need to think that this region and this region are equal. What does it mean? That means we need to prove triangle COD should be congruent to triangle AOB. Let's see how we can prove it. So this is the given diagram. Okay. So we'll compare the two triangles, triangle OCD and triangle AOB, right? And we see that there are 3 points that we can think of. The first point is CD is equal to AB. It is given, right? The second thing is OC is equal to OA is equal to OD is equal to OB. Why? Because this is the radius of the circle. We know that property of the radius, it should be equal. So what we can say that through which property? Can you guess? Pause the video, think which property? So through SSS or side property, we can say that triangle OCOD is congruent to triangle AOB. Okay. So here we can say that this is not an end. We need to prove that the angles are equal. So we can write that further angle COD will be equal to angle AOB through CPCT. Corresponding parts of congruent triangles are always equal. So we can write angle COD is equal to angle AOB. So what we proved? That if the chords are equal, any two chords of a particular circle are equal, then the angles subtended at the center are also equal. We'll apply this property in many questions. So remember it. What can be the converse theorem? If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So you can see that if the angles are equal, the chords are also equal. Okay, let's go to the third theorem. So third theorem is the perpendicular from the center of the circle to the chord bisects the chord. Okay, what does it mean? Let's see. So if this is a circle, this is a chord, say A and AB is the chord, this is the center O, okay, and we are drawing a perpendicular or 90-degree angle at the point P. So the given thing is that OP is perpendicular to AB, and we need to prove AP is equal to PB, because we need to prove that this line OP bisects the chord, right? So how can we prove? Again, we have to take help of the congruency. So let's join AO and OB. So after joining, think about that. How can we prove that they are congruent? Pause the video and think about that. So if you see, comparing the triangles OAP and OPB, we see that there are again 3 points. The first point is angle OPA. If you see that OPA is equal to what? Angle OPB. What is the value? We know that it is 90 degree. It is given, right? The second thing is that OP will be equal to OP. It is a common side of the two triangles OP. The third thing we can write that OA is equal to OB. Why? Because they are the radius of the same circle. So using which property? We can say that using RHS property, OAP is congruent to triangle OBP. And through CPCT again we can say that AP is equal to PB. And hence what we can conclude? That if the line from the center to the chord is 90 degree or perpendicular, then it will always bisect the chord. Okay, it will divide the chord into two equal halves. Hence proof. So you can say that what will the converse theorem? Converse theorem is the line drawn through the center. So if it is given that the line drawn through the center of the circle bisects the chord, if this is given, then it will always be perpendicular. So even if it is either one is given, then the other one will be true. So here, if AP is equal to PB, then OP is perpendicular to AP. Clear? This is the fourth one. So the fourth one is equal chords of a circle are equidistant from the center of the circle. Equidistant means it is the same distance. So if the chords are taken equal, then the distance from the center will also be equal. Let's see this. So if this is a circle, this is a chord of equal length. Let the chords names be AB and CD. Okay, this is the center O, and we are given that PO and PO and QO are the distance from the center. So it is given that they are equal. Chords are given that AB is equal to CD, and we need to prove that PO is equal to QO or OP is equal to OQ. Okay. So how can we prove? We'll do a simple construction here, right? And we will compare these two triangles, if you see. So we are comparing the triangles APO and CQO. So After construction, we can join, and what we'll assume here, this is very important part, we will assume that OP and OQ are perpendicular distance because it is the shortest distance. So we will assume that it is the, since we have to find that they are equidistant, right? Equidistant means we'll always assume that it is the perpendicular distance. So we'll assume that it is 90-degree angle. Okay. This is just a thing that I have solved it. You can pause the video and see, have a look. It is only the RHS, through RHS we can see that if the chords are equal, then the chords are equidistant from the center. That is PO is equal to OQ. So the converse theorem will be that if the chords are equidistant, then the chords are equal in length. That is, if OP is equal to OQ, then we can write AB is equal to CD. This is the fifth one. So the angle subtended by the arc, we know that the arc is the portion of the circumference. So the angle subtended by the arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, let's see what is this one. So if this is a circle, this is the center, okay, this is center O, and PQ is an arc on the circle, okay, and here we are joining the points PQ, so this is forming an angle at the center, right? So, and what is according to this theorem, if we take any point outside this arc on the circle and we join them to P and Q, it will form an angle, right? So this angle is half of the angle that is subtended at the center. That we need to prove. So let's see what is proof. Just now I told that angle POQ will be equal to twice of angle PAQ. Okay. So let's do a simple construction. We'll join AO and extend it to point B. So we are joining it so that we can form triangles, because the congruency, or with the help of the triangles property, we can prove that this angle is twice this angle. So let's prove it. So let's name these angles as angle 1, angle 2 and angle 3. Can you think? Pause the video, think. What type of angles are it? Yes, you are right. These two are interior angles and this angle 3 is the exterior angle. So we'll use that one. Okay. Let's name the other angles as well. So we can see that angle 1 plus angle 2 will be equal to angle 3, just with the exterior angle theorem. Also, we know that angle 1 is equal to angle 2. Why? Pause the video and think. Because it is the radius, right? AO and O is equal to OP, and it forms an isosceles triangle, right? And in an isosceles triangle, these angles are equal. So we can say that angle 1 equal to angle 2. So what can we conclude from these two statements? That twice of angle 2. So we are substituting angle 2 plus angle 2 we can write. So twice of angle 2 is angle 3, right? Hence, this is the point 1. Similarly, what we can write? Just similarly, we can write twice of angle 5 is equal to angle 6. Okay, and this is equation 2. So we are just adding equation 1 and 2. We are adding them. So what we get? Twice of angle 2 plus twice of angle 5 is equal to twice of angle 3 plus twice of angle 6, right? And what is this one? This forms an angle PAQ. So you can see 2 and 5 angles forms PAQ, right? So this will be equal to angle 3 plus angle 6 is what? Angle POQ. It is the point that is the arc is forming, right? So hence we can say that the angle that is formed at the center by a particular arc, it subtends an angle whatever point we take on the circumference, that will be half of it. So this will be less and this will be more. Remember, we are not taking the point at this side of the arc, on the arc. We are taking outside the arc. That is very, very important, students. Please remember it. Okay. So we are not taking point A on the arc. We are taking the point A outside the arc. Question time. Okay. So Prove that the angle in a semicircle is 90 degrees. Write it in your notebook, send it to me through email. Okay, so what we have to prove, this is the diameter. Semicircle means it cuts the circle into two equal halves. So this is the diameter, let it be points A and B, and we have to prove that any point, whatever point we take it, for example C, this angle ACB is 90 degrees. Okay. Second thing, let's find the value of x. Be ready, students. This is a given question. This is a circle. This is the diameter, center O. So AB is the diameter. This is a point C. Okay. This angle is x. This is given as 35 degree. You have to find x. Starting the timer. Options are 40 degrees, 45 degrees, 50 degrees, and 55 degrees. Yes, you are right. It is 55 degrees. Carry on, students. Second question. We have to find the value of x in this following diagram. So it's given that O is the center of the circle, AB and AC are the chords, AO is the radius, right? You have to find the value of x. Your time starts now. Possible options are 100 degrees, 115 degrees, 110 degrees, and 120 degrees. Yes, you are right. It is 110 degrees. Well done, students.
So students, we have come to an end of our today's class. I hope that you have understood the basic concepts and theorems on circles. Don't forget to attempt some of the challenging questions and share the answers with me in the comments. Thank you, and I'll see you soon.